Hey guys, today we are talking about systems of inequalities. So remember when we did graphing regular inequalities, we will talk about if we shade above, shade below, if we had a dotted line, if we had a solid line, okay? So remember, if we have less than, it is a dotted line and we're going to shade below the graph. If it is greater than, it's going to be a dotted line and we're going to shade above. If it's less than or equal to, it's going to be a solid line, we're going to shade below. And if it's a solid line, and then if it's greater than or equal to, it's going to be a solid line, and we're going to shade above. Now, the only things that we really need to remember is this, and then how to graph a line and what my solution set is. So if this is a systems of inequalities, wherever my shading intersects is a solution, but it has to be a solution for if there's two lines, it has to be where those two intersect. If there's three, it has to be where all three intersect. Okay, and so we have to be very particular with what our answer is. Let's start off by remembering our y equals mx plus b. Remember, whenever we graph a line, we want to solve for y first. And remember, my m has changed colors. My m is my slope. Okay, that is my rise over my run. Next thing to remember is my b. My b is my y-intercept, or in other words, where my graph intercepts the y-axis. All right, so let's take a look at this first guy for us here. Okay, so we have two lines. We have this blue line here. We have this blue line here, and I have this red line here. So we're first going to look at the lines, and we're going to start anticipating what is the y-intercept, what is the slope, all of that. The first thing we're going to do, though, is it a dotted line or a solid line? It is a solid line, right? It's not dotted, it's a solid line. So looking at my answer choices, I know that it's not A, and I know that it's not B, okay? So I know it's not A or B, because those only use less than or greater than symbols. And if they only use less than or greater than symbols, they would be dotted lines, but these are solid. Next, we're going to look and see if we shade above or if we shade below. Well, for the blue one, we shade above, right? What about for the red one? Yeah, we're going to shade above again. Think about what's above it, and that's going to be what we shaded. Now, this section here, the section where they intersect, that is what's called my solution set. If they didn't intersect at all, we would have no solution. But since they do intersect, there is my solution. Okay, so now, since I know that we shade above for both of them, that means we're going to have greater than or equal to symbols for both of them. This one has a less than, so this one would shade below, so this one isn't right. So C is not a correct answer. So I know my correct answer is going to be D. But let's double check our y-intercepts and our slopes. This one right here, my slope for this first one, this blue one, is going to go up 1, over 1, up 1, over 1. And so that means my slope is 1. Hey, that checks out. My slope's 1 right there. And I have a y-intercept of 4. Hey, that works too. Okay. And then my other one, we have a y-intercept of -1. That works. And I have a slope of -2. Well, my slope is negative here. Let's see how much we have. It goes down 1, 2, over 1. So that is obviously the correct answer. So let's use this information and let's write this stuff for number 2. So number 2, it says write a system of linear inequalities represented by this graph. Okay, so let's do each line individually. So let's start with this dotted line right here. Okay, this one right here. We're going to use blue to represent this one. All right, so I'm going to start with my y, and then we're going to find my y-intercept next. So my y-intercept is going to be right there. Now it's hard to see where my axis is, right? My axis is somewhere up there, and it's covered by the solution set. But it's going to be down 1, 2 from my axis. So my answer for the y-intercept is going to be -2. Okay, what about my slope? Well, let's pick 2 points on this, and let's go up 1, over 1, 2. Okay, so my slope is going to be 1/2 x. But now it's the hard part. Now we need to figure out, is it going to be greater than, less than, what's it going to be? So when we look at this, I'm going to say it's going to be greater than, because the solution set is above this line, okay? Then, since my solution set's above and we have a dotted line, it is not equal to, it's just greater than. Okay, so that's that first one. Let's do our next one. Let's do this dotted line going down. So this dotted line going down. Well, let's see where my intercept is. Well, we're going to have an intercept right there at 1. So we're going to have a y-intercept at 1, and then we're going to find my slope. Here's 1 point, here's another point. We're going to go down 1 over 1, 2. Okay, so my slope's going to be 1/2 x. Hold on, though. It's also going to be a negative 1/2 x because it is going down. So you have negative 1/2 x plus 1. All right. Now we decide, is it going to be less than, greater than, less than or equal to, greater than or equal to? Well, first off, is it a dotted or solid line? It's a dotted line. Second, am I going to shade above or below it? Well, my solution set here is below. So we're going to go less than. Last one. I have this solid line. Right here, okay? And it's straight up and down. What do we know about straight up and down lines? Yeah, they have a x right here, not a y, because it is undefined. Now we're shading to the right of this, and it's a solid line, so this one's going to be greater than or equal to where x is greater than, and it's going to intersect here at -3. So remember, that is an undefined slope, but it still works for our graph here, so it's very important to pay attention to all that. Okay, next up, we're going to tell whether each ordered pair here is a solution of the system of linear inequalities. So what can I do? I can take each one of these. Remember, this is an x value, and this is a y value. And we can plug these in to see if they are solutions. So let's plug this 1, 0 into my first one. To be a solution, it must check in all inequalities. So it's going to have to be true for each one of these inequalities. So let's see. So this first one, y is less than. So we're going to plug into this first one first. But I'm going to go ahead and replace y with 0. And I'm going to replace that x with 1. Hey, is 0 less than 4 times 1? Yeah, it is. So this one's true for this one. Okay, let's try the next one. Let's plug in 0 for y. We're going to 0 is greater than. 0 is greater than or equal to 1 minus 1. This is our second one right here. Well, 1 minus 1 is 0. Is 0 less than or equal to 0? Yeah, because of that equal sign right there, this one is true too. Okay, now let's try this last one. Is 0 less than or equal to 2 times 1 plus 1? I'd say it is. Well, let's check it. 2 times 1 is 2. 2 plus 1 is 3. And so that's definitely greater than or equal to 0. So this one checks out as well. So all three of these do. So the answer to this, is it a solution? We're going to say yes, it most certainly is. Okay, now let's try out this b over here. All right, so this b, we have -2, -8. Let's plug this in. I'm going to switch colors so we can have plenty of space to plug in. So I'm going to go -8 for y is less than 4 times -2. Okay, 4 times -2 is -8. Oh, is -8 greater than -8? No, it's equal. And this doesn't have an equal sign, so this one is a no. Remember, if it's wrong on just one, it doesn't count, so we don't even have to check the others. So this one's just going to be a no, it is not a solution. Okay? That's all you have to do to check. And you can do that on any of these. The other way is we would check and see if it's like in the graph. We'll do that in a little bit. Okay, let's turn the page and let's graph these three. We have y is greater than or equal to -4. And I have y is less than or equal to -x plus 2. And I have y is less than 2x minus 2. So let's graph these real quick. If y is greater than or equal to -4, remember we're going to use a solid line. We're going to shade above. And we're going to put here at -1, 2, 3, 4. We're going to put a big point right there. And I know this is going to be a flat line. There's no x value. So it's just a horizontal flat line. So this one's going to be like this. And I'm going to shade above, okay? Maybe I can do that a little bit better. Let's see. I'm just going to point that we're going to shade above, okay? That way we don't muddle everything out. We can shade later. All right, next, we're going to have y is less than or equal to negative x plus 2. So I'm going to pick a different color. And once again, we have a less than or equal to. So this is going to be a solid line. And then we think, okay, my slope is negative 1, right? And my y-intercept is 2. So we're going to start at 2. And we're going to go down 1 over 1, down 1 over 1, down 1 over 1, just like that. And so then, there's my graph. It's a solid line, and it is less than. So we're going to shade below. Okay, my last one. Y is less than 2x minus 2. Okay, different color. This one is just a dotted line. And it says 2x minus 2. So my y-intercept's at negative 2. So we'll do that first. And I'm going to have a slope of 2. So we're going to go over 2, up 1, over 2, up 1, over 2, up 1. And we have a dotted line. Okay, so we're going to go dotted line right through there. And then this one is less than. So we're going to shade below. Okay, look. If we shade above the red, below the green, and below the blue, we're going to fill in this solution set. Remember, the solution set is where all three come together. So my solution set here is going to be this purple triangle. So now, let's answer this question. Is the point 3, comma 2 in the solution, where x is 3 and y is 2? If we go over 3 and up 2, we're going to put a point right there, over 3, up 2. So is that a solution? I'm afraid not. No, it is not a solution. Okay, so that one's a big no. Okay, now, number 5. Number 5. Let's graph this guy. We have y is greater than x plus 3, greater than or equal to x plus 3. So once again, we're going to start off with a y-intercept of 3. And it's just x, so my slope is 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, down 1 to the left 1, down 1 to the left 1. So, oops, that is not a good line. Let's try that again. Let's erase this little dot. All right, let's try this. Okay, that's a lot better. All right. Okay, and we're going to shade above. All right, now let's solve this one. Let's minus 2 to both sides because we want to get y by itself, right? So we get y is less than x minus 2. Okay, so y is less than x minus 2. So we have a y-intercept at 2. And my slope is 1 again, so we're going to go up 1 over 1, up 1 over 1. But this is a dotted line. Dotted line. And we're going to shade below. Uh-oh. This one's shading above, this one's shading below, and those are parallel lines. Hold up. We're not going to have any connection because we're going to shade all of this in blue, shade all of this in red, and my green, let's do my green real quick. Let's minus 2x here, minus 2x here, okay? And we get negative y is less than negative 2x plus 4. But then I have to divide both sides by negative 1, right? So that's going to give you positive y is greater than, because we have to flip the sign whenever we divide by a negative, is greater than 2x minus 4. Okay, so now this one. We're going to have a point at negative 4, and we're going to go up 2 over 1, up 2 over 1. So it's going to be a dotted line like that, and I'm going to shade above this one. Okay, so listen, I don't have any spots where all three intersect, do I? Because my red is up here, my blue is down here, so there is no solution set. So this one, I wouldn't actually shade anything in, and I would just say no solution set. If there is no thing where all three combine, there's no solution set. And so is 1, negative 2 a solution? 1, negative 2 right there? No. And it couldn't be. Okay? Because it has to fall into the actual solution set, and there is none here. All right, last page. Number 6. Mrs. Martinez's Cookie Factory makes different size packages of cookies that contain a combination of chocolate chip and peanut butter cookies. So let's let X be chocolate chip. Okay, and let's let Y be peanut butter. Okay, write inequality to represent each constraint. All right, so the first one, Mrs. Martinez places at least 3 of each type of cookie in each of the combination packages. Okay, so there's at least 3 types of cookies in each of the combination packages. So that means that my X is going to be greater than or equal to 3 because we have at least 3 chocolate chips. That also means that my Y is going to be at least 3 because we have at least 3 peanut butter. Okay? And the largest package contains 13 cookies. So it's going to be 13 or less. The largest contains 13. So my third equation is going to be X chocolate plus Y peanut butter is going to be less than or equal to, because the largest one is 13. So now let's graph this system of equations. This is going to be my x-axis, this is going to be my y-axis, and we can count out here that this is going to be just my regular numbers. We'll go 2, 4, 6, 8, 10, 12, 16, okay? And we'll do the same thing going up, all right? We'll go 2, 2, 4, 6, 8, 10, 12, and so on and so forth, okay? So then, my first one is going to be for x is greater than 3. So if x is greater than 3, remember that is a line right here, and we're going to be greater than it. So we're going to fill into the right, and it's going to be a solid line. The next one, y is greater than positive 3, okay? So if y is greater than positive 3, then we're going to have to go y, that's going to be a flat line. So we're going to do a flat line here. And we're going to say y is greater than this. We're going to fill in above it. And last but not least, this one. Well, I have to first solve this for y. So I'm going to have to minus x to both sides, right? So I'm going to minus x here, and we're going to get y is less than or equal to negative x plus 13. And now we're going to graph this. My y-intercept is going to be at 13, and we're just going to go down 1 over 1, down 1 over 1. So it's going to look like that. All right, so this, and we're going to show you below. So this shows us what my solution set is for all of my cookies. Okay, shows me what my solution set is for all of those. So we graphed the system of inequalities and we found the corners. Okay, my maximum corner here would be we could have 10 chocolate chip and we could have 3 peanut butter. We could have 3 chocolate chip and 10 peanut butter, or we could have at the very minimum 3 of each and only have 6 cookies in a package. All right, so those are the corners of what we could have. All right, so here we go. The profit on a chocolate chip cookie is 25 cents, and the profit on a peanut butter cookie is 26 cents. Okay, how many of each type of cookie should be produced to have a maximum profit, and what is the maximum profit? Well, we make more money for peanut butter cookies. So we would want to put all we can in the peanut butter and little in the chocolate chip, right? So my maximum profit is if I had 10 if my maximum profit would be if we only did 3 chocolate chip and we had 10 peanut butter, okay? So that would be my maximum profit. Now, 3 times my, let's put in my chocolate chip profit. My chocolate chip profit is going to be 25 cents. And my peanut butter cookies is going to be 26 cents. So now, if I work this out and I add those together, okay, we'll have 75 cents here and I'll have $2.60 here. Add those together, 260 plus 0.75, we're going to get $3.35. So my maximum profit is going to be $3.35. Okay? So that is how we decide what is our maximum. It also tells us how much we could get in a package if we're just buying random packages. Okay? All right, guys. Hope this video has been some help. Remember, always think y equals mx plus b, and then decide if it's going to be above, below, dotted line, or solid line. All right, guys.